Okay, we're picking up with 3.2 implicit differentiation lesson notes, and this is part 2C, and so it's the third video in part 2. And I wanted to talk a little bit about completing the square with this one and how we can identify what this graph looks like. Finding all points on the curve, 4x squared plus y squared minus 8x plus 4y plus 4 is equal to 0. So if you recall when we had circles in the general form like this, we could put them in the standard form and we could easily graph them by finding the center of the circle and the radius. We're going to do something similar with this, but first we're going to take our equation that you see with the x's, the x terms in red and the y terms in blue, and then I threw the plus 4 that you see here, I put that on the right-hand side. Okay, I'm going to zoom in on this. So then what I did is I'm completing the square. I'm completing the square in x and in y. But recall that the a, the leading coefficient of the x squared or the y squared term, must be 1 in order to complete the square. So you can see that I factored the 4 out of the two terms, and then I put a blank in there and highlighted it yellow. And then whatever I add to the left, I have to add to the right as well. And then I did the same thing. I highlighted it in orange where I was going to complete the square in y. And then what I add to the left there, I've got to also add to the right. So once I did that then, and recall that when you complete the square, you're just adding b over 2 squared, and b is the coefficient of your middle term. So for instance, with the first trinomial, I would say negative 2 is b. So negative 2 over 2 is negative 1 squared, and you're going to get 1. So I add 1 to complete the square, so to speak. Okay, so on the next line, you can see where you have 4. Let me see. Do I have a little pointer here? Yeah, here. So we have 4 times x minus 1, the quantity squared, and then I have y plus 2, the quantity squared, is equal to 4 because the two 4's cancel, negative 4 and 4 cancel. And then to put it in the form that we want, what we're going to do is we generally want this right-hand side to be 1. And you can see that the ellipse equation down here is then x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. Now, I have the y term second with the a squared at the bottom, but a squared is reserved in ellipses to be that axis that is the longest. And in this case, the y, or the vertical axis, is going to be longer. Okay, so we have the center is then at 1, negative 2. And in this case, we put the center there at 1, negative 2. And then the b in this case, since b squared is equal to 1, b is equal to 1. And you go from the center out to the point on the ellipse. Go 1 unit. You can see both directions. From the point 1, negative 2, I go left and right along a horizontal axis to the point that's on the graph. So I go from 1, negative 2 to 0, 0, negative 2, and then I go from 1, negative 2 to 2, negative 2. So that gives me a couple points there. And then a squared is equal to 4, so a is equal to 2. And so I start at the center, and then I go up to the point 1, 0, and then I start at the center again, and then I go down 2 points to the point 1, negative 4, just so the graph can make sense to you. And when we're talking about derivatives, sometimes, it's better to see, okay, we have a derivative now, and we work through that, through all the steps like we've done before, factored out a 2, and then simplified it to where I get down to this step. And now the question says you want to know where the tangent lines are horizontal and where they're vertical. I think I put them, mixed them up here, so let's move those. So where are they horizontal and where are they vertical? So if the tangent lines are horizontal, you're probably thinking to yourself, well, I can see perfectly. It's got to be here where they're horizontal, right? And so let's just verify that with the derivative that we were able to get. Again, implicitly differentiating, and then getting all the dy dx on one side, everything else, every term that doesn't have a dy dx on the other side, and then solving for dy dx, and then simplifying. We get 4 minus 4x over y plus 2. So I want to find the place where the tangent lines are horizontal. And you're saying to yourself, it's where x is equal to 1, right? So we would then take this and say, well, where is dy dx equal to 0? So we have 0 is equal to 4 minus 4x over y plus 2. And the only place a fraction is going to be truly equal to 0 is in the numerator. So you can multiply both sides by y plus 2, and you would get 0 is equal to 4 minus 4x. And you can see that you would get x is then equal to 1 by solving. So we get x is equal to 1. Now, to find the y value, you would have to put it back into the original equation mathematically, if that's what you were going to do. So you would say 4, and I'm going to do this one time with this, 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 would have to equal 0. So you would end up, this would be 4 plus y squared minus 8 plus 4y plus 4 equals 0. And so you would have to solve this quadratic, y squared plus 4y. And then you would add all the other terms up, right? So you would have 4 minus 8 and minus 4, right? So did I do everything right there? 4 times 1 squared plus y squared. Oops, sorry. Y squared minus 8 plus 4 minus 4. I guess that's all we get, like this, right? And then it seems like something's off there because I probably should get 0, and I do. 0 and negative 4. So we factor out a y, and then we get y plus 4 equals 0. So we get y equals 0, and y is equal to negative 4, which you can see the points then would be 1, 0, and 1, negative 4. So you'd have to go back, and that would be the method that you would use to verify the points. You're looking at a graph, so you were able to see, oh, I can see exactly where those points are, but not always as evident, and that gives you the work to show you that. Okay, so you get the x value is 1. Now then when you say the tangent lines, and I'm not going to go through this process again with the other ones, but where the tangent line's vertical, so let's use brown, I guess. So I would go like this, and you can kind of see on the edge, the ends, that's where they are, right? On the left and right vertices. These are all, the vertices on the top and bottom, they're called the vertices, and then the on the left and right, those are called the co-vertices. But so the co-vertices is where you have the tangent lines being vertical. So that's going to be where this is undefined. The derivative is undefined. So you would just say that would occur when this thing, y plus 2, is equal to 0, or y is equal to negative 2. So once you would get that y value, then you would be plugging that back in to get the x values. But I'm going to make a long story short here. And I'm going to say we have the y is equal to negative 2. And if you wanted to, you could plug it back in, and then you would get the x value. You could plug it back in the general form. But then we would have those 2 points. We would have 0. We would get x is equal to 0, and then x is equal to 2. And then we would say the 2 points would be 0, negative 2. And at, 2, negative 2. Okay? And there you have it. There you go. There it is. Okay? And so that finishes up this last video for you in this part 2, part A, B, and C for the videos. And that'll give you a little more to go on in terms of the content for this section. So I hope you have a nice day, and I will see you when I see you. This is Alanator out.